Now, section 7.4. Section 7.4 basically is talking about once we learn a new notation, then next you need to learn how to do multiplication, addition, subtraction, division with the new two notations. Now, if you had two functions, how you multiply them, how you plus them. And actually, functions can be expressed by the graph. So if you have two functions presented by the graph, how you multiply two functions, how you plus two functions, or subtract, or divide. Actually, we don't do that. So the real things the question asks you to do if function f and g are two functions, yes. Then, do we really plus these two functions? No, we never just plus two functions. Actually, we try to plus two function value. Okay, function value. So this is y1. This is y from the function f. This is y from the function g. So basically, we are plus two function value, or we plus two output. Okay, so output mathematically they are real numbers. So it's not hard. I ask you to plus two real numbers. So nothing new. Okay. Now something scary is when you see f plus g. So again, we don't have f, but we do have f of x. We don't have g, we do have f of g. Now, if I ask you to have f plus g, you cannot do anything without input. So you can see that they ask you to try to add the two functions with the input x. So we won't just ask you to plus two functions. You need to input x. Okay. Now this notation plus, what it means? Let me erase those marks and then because I need a space to write down something for you. Okay, so on chapter 12, you are going to learn something called compositive functions. This is the new notation, but we are not going to learn this right now, okay? This type of notation is if you input a x to a function g, and you use this output to input the two function f. So this type of the process, we don't call it plus, we don't call it multiplication or any operations. We have a new notation. But here today, right now, we don't learn this very complicated thing. We only learn addition, subtraction. Now, addition, subtraction, f plus g, input x, basically is same as you input the x to the function f and the plus you input. Okay, so if we talk about the graph, if you have function f and the function g, how you plus them together. If they input to the input with the same x, so with the same x input, you are going to have g of x. And the same x here, you have f of x. You try to plus these two values, g of x plus f of x. So fx plus g of x is about here. Okay. So if I try to for example, if this is G and this is F, okay, how I plus them together with the same X? So F plus G here, F plus G here, F plus G, okay, F plus G, F plus G. So F plus G. Okay, so I connect together. This is F plus G. Okay. So if you have same X to input, then you just plus the Y value together. Now, again, mathematicians are always very lazy. So they consider, since we have same X, why not we only write down the same X one time? So basically, F plus G input the same X is the same meaning for X input to F and X input to G, and the Y value from function F, Y value from function G, you plus them together. So basically, we plus two real numbers together. Okay, so keep in mind, two functions plus together is not that complicated or scary. It's just two real numbers plus together. And the subtraction, same thing. It means f of 2 minus g of 2. So this is a real number. This is another real number. That's all. So let's try the real examples. Number 3. Now, this section is pretty easy, but on the test, if you say, teacher, I'm so genius, I mental calculate everything and I can have 319 for the answer without showing the work, then very sorry, your teacher is not a genius. So I assume my students not smarter than the teacher. Okay, I assume, I know you are all smarter than me, but your teacher will ask you to show the work, so I feel more comfortable. Okay, so how you show the work? Let me, I show my work here, you need to follow me, but let me talk about how to show the work one time. Okay, so f of x, don't write down x, right? You use the parentheses. And this is f of x. G of x, you write down here, g of x. Right? And this is f of x. And instead of write down the x, you write down 10. And instead of write down x, you write down 10 here. Now the rest is just simplify. Simplify. and simplify. In the end, we call this evaluate, because once you plug in, you want to evaluate. And the process of the evaluate, you want to simplify the expression, and this means multiplication, okay? And the square make a negative positive. So I show all the work here. You want to read, and if you think about your foundation is not strong enough, you want someone to help you with the calculation, I will ask you to show your work, even though that's a mistake. That's okay. So when you show work and I fix your mistake, that's the best way to learn how to calculate perfectly without mistake, without careless mistake. Okay? So you go home, try. And then if you try 3 times, you still don't get it right. That's one thing I want to mention is for the homework session, you may try many times, okay, till you get it right. But as I will consider if you try 3 times, you still don't get it right, then you want to show me your work, and I want to check what's wrong with you, and then I can fix your problem. Okay, again, that's the best way to learn how to calculate. Number 5, this is the same thing, but this time is the multiplication. So multiplication, you want to calculate f function, and then want to calculate g function separately, and then after that multiply. You are allowed to use calculator to help you with the calculations. Number 6, subtraction. Subtraction, same thing. I will suggest that you separate f and the g. If you want to distribute, that's okay, but you don't need to because they are all real number. You may combine 36 minus 9 first. Number 7, plus. So you plus these two functions. This is f of x, and this is g of x. How you plus them? Combine the like term. There's one thing I want to emphasize here is when you see this notation, the purple color, okay? When you see this notation, this x is the input, and the f plus g become a new function. Say this is h of x. So we say h of x or f plus g of x. It's not a multiplication, okay? This x is input. This is input, not a multiplication. So some students, they plus f and g. And after that, they try to multiply with x. That's wrong. Don't do that. Don't multiply with x, okay? You already input x. X is already been input here. Okay, it's input. Input. Understand? So don't multiply with x. Same thing to the previous question. Okay, this not the case. Let me show. Okay, so this 2 is the input 2, not the multiply with 2. It's not the multiplication. So number 9, here, subtraction. Again, subtraction when you want to input with 8. This is not the multiplication, it's just input. Input. So when you input, did I input? Oh, I didn't input. Okay, so I need to input 8 here. Okay, input 8. That's the input 8. So in the end, I have 64 plus 8 minus 28. So it's 64 minus 20 equals to 44. So this answer is 44. Do you have to multiply 8? No, don't multiply with 8. This 8 is not a multiplication, it's input 8. Okay, so when you have f minus g, you want to write down as f8, f of 8, subtract g of 8 first. So this one is this one. This one is this one. Okay. Now next, number 10. This k is input, not the multiplication. So if input the k here, and the f of k, this one. G of k, well, I need to change it to k, right? G of k. Now when you have binomial, you multiply, because they ask you to do multiplication, multiply by FOIL, F-O-I-L. Now let me review how to multiply by FOIL, and I forgot to change it to k, not x. Okay, I need to change it to k. Okay. Now multiply by FOIL. This is the first term, last term. Multiply first term, last term, and the FOIL is F-O-I-L. First time first, first time first. Last time last. This one, last time last. O means outer product. I means inner product. Inner product, you multiply inside these two numbers. Outer product, you multiply outside these two. Okay. So let me erase the ugly mark so you can see better. Oh, okay. Let me rewrite. K square minus 17, 3 minus k equals to f times f is k 3k square, right? 3 times k square, first time first. And the outer product, negative k times k cubed, so next negative k multiplied k square, so negative k cubed. Inner product, 3 times 17, negative 51. Last term times last term, plus 17k. So if you rearrange by the descending order, the highest degree, negative k cubed plus 3k squared plus 17k minus 51. Number 11, division. Now when you do division, the g become in the denominator. So you want to take a note. The denominator don't supposed to be 0, therefore s cannot be 3. And the number 12, you have addition and with the same input. And basically same function plus. So it's just 2 times, right? 2 times. Number 13, multiplication. These two functions you want to multiply. So function r multiply function t, and denominator multiply with denominator, numerator multiply with numerator. That's multiplication for the fraction. Number 14, subtraction. Subtraction is a little harder because when you don't have the same, when the denominator are different, you don't supposed to directly plus them together. So you need to find the least common denominator. Least common denominator. How you find least common denominator? In this case, you multiply 7 to have both 7, and you multiply x to have both x squared. So you have 7x squared. Okay. If you don't remember how to find the least common denominator, something asked me in the class time, so I will review for you. So once you have same denominator, then you simply subtract the numerator. 77 minus 12x. Number 15, subtraction. I show my work here is very long calculation, and after you subtract, you need to find the least common denominator. So let me show you x minus 9 already there, right? X minus 9 already here, and so when they have the common x minus 9, then there's a common denominator, one of the factor. X plus 9, you don't have x plus 8, so you need to multiply x plus 8 multiply x plus 8. Okay, and the right hand side fraction has x plus 8, but there's no x plus 9, so I multiply x plus 9, x plus 9. So when you multiply something for the denominator, you need to multiply the same thing to the numerator to make sure you multiply 1. Okay? Any fraction multiply 1, 3/4 multiply 1 still 3/4. You are not going to change anything. You multiply 5/5 is 1. Okay? So if you multiply x plus 8 for the denominator, you need to multiply x plus 8 for the numerator to keep the same fraction, same value. So once you have the same denominator, you simply subtract the new numerator. So new numerator is x plus 1, x plus 8, minus x minus 1, x plus 9. Okay, now there's a big calculation. Binomial multiply by FOIL. F-O-I-L. Binomial, you multiply by FOIL. Okay, now x squared subtract x squared is gone. And 9x subtract ax is x, right? A take away negative 9, become a plus 9. A plus 9 is 17. And then for the denominator, you don't need to multiply, okay? Just leave the denominator as it is. That's good enough. Okay. Number 16, division. When you have division, if you have 3/4 divide by 5/3, for example, it means division. Or you can write down 3/4 divide a fraction, the bar means division. You can do this way. Okay, but both are not easy to calculate. So F over G this type of fraction, if f is already a fraction, and divide by another fraction, you are going to see it's so complicated. So we don't work on the fraction or division this way. Now I want to show you how I calculate. If there's a division, so first by the definition, you want to input x to each function and you have division. This division means multiplication to the reciprocal. To the reciprocal. So when I write down 1 over g of x, what it means? It means the reciprocal of the function g. So this is the reciprocal of g. Reciprocal of g, you simply just upside down numerator, denominator, become denominator, numerator. Just upside down the numerator and denominator. So you can have division become multiplication. Now you need to factor. After you factor, then you can reduce. Because same thing divided by same thing is 1, right? So you can reduce. After reduce, numerator multiply with numerator. Denominator multiply with denominator. Number 16 is complicated, but it's a very good review for you. Number 15 is the same thing. Okay, number 17 comes the two graph, two function need to be subtract. So I say the function subtract basically are the y value subtract. So you simply find the y value and the subtract. That's all, not too hard. Number 18 is complicated. So my first time, I feel it's hard to understand. So I still want you to read it first, but I give you a very nice hint. This function means e, but this function is not an m. This is not an m, okay? This function is e plus m. You have to understand that, okay? E plus m together. So m only this big. So in order to reach this height is e plus m. And this function is not f. This function in the end called f. But this function is not a w. Okay, w only this big. So if you plus e plus m plus w all together, we call it f. So f is the total. Now, let me erase my new mark here so you can see better. So I would like you to read the question and then read my work first. But this is harder, so I show you. This function, this graph is e plus m, and f is the top function. So when 1990, the f value is 64 here. Okay, 64,000. So this question, I think my work show very detailed is that, and also I show you the function is the total function f is all three together, I think then you're supposed to understand. If you still have questions, you may ask during the class time. Number 19. Start from number 19. It's a little hard because when you have two functions, these two functions individually they have their own domain, and when they plus them together, how you find their domain together? Okay, so say if you have a function, let me use graph to explain easier. Okay, if you have a function domain is this big, and that's a function value, and the other function, the domain from here, and that's the function value up to there. That's a domain only here. So if you try to operate these two functions together, the new domain is supposed to be only from here to there. Make sense? Okay, so that's a new domain. If they are all real number, then all real number, but sometimes not the case. So number 19, f, you don't see denominator, you don't see square root, even root. So domain are all real. Therefore, plus minus multiplication, domain is still all real because they have same domain. Okay. But when you talk about division, then you need to add one more condition. You don't want the x to be 2 over 9 to make a denominator equal to 0. Now, this homework, they don't ask you the domain for the division. So just think about addition, subtraction, multiplication. So when you have addition, subtraction, multiplication, you are not going to create any denominator. If you are not going to create a new denominator, then you don't need to kick out anything extra. Okay? So you just need to combine the domain from f and the g. Then that's good. Okay. So number 20, the domain of f, x not 0. So if I graph the domain x not 0, there's a hole there. And for the g, the domain is all real number, and the f is all real number except 0. And if you combine these two together, I will say this 0 need to be kicked out because f has no 0 in the domain. So there's no way you can plus these two output together. There's no way. So combine these two together, then x is not 0. Number 21, for the f function, you kick out negative 3 over 2, and for the function g, you kick out 1. So if you plus them all together or subtract or multiply, you need to kick out both. Okay. Number 22. Number 22, that's only one number need to be kicked out. Number 23, something negative 5 is not allowed. But, number 22 and 23 is different because they are talking about division, right? So, yeah, for the function f all real and the function g all real, but when you divide, you need to kick out negative 5. Why? Because when you divide by g, this function g becomes the denominator. Number 23. The f function itself already have denominator. And even though g, the domain of g is all real number, but right now g is become the denominator. So originally x not equal to -5. And because the function g become the denominator, right? So 2x plus 7 cannot be 0. You kick out -7/2. So how do that? 2x plus 7 equals 0. 2x equals to -7. S will be -7/2. And then you just kick out this number. 24. When you have two functions, how you subtract these two functions? Basically, the input is 3. So you input 3, 1, 2, 3. Here you find this value is 0. And the y value, okay, that's the y value. And the y value here is 1. So 1 minus 0. So basically, just real number subtract real number. Last question. Last question, let me see. Okay. The blue color is function f. And the green color is function g. How you plus them together? Again, the domain for the f is from 0 to 9, right? Domain for the blue color, no, this color is from 0 to 9. And the domain for the g is from 5 to 10. So if you want to operate these two functions together, the only choice, the domain will be from 5 to where? To 9. From 5 to 9. Okay? You only need to worry about the addition from 5 to 9 when x is 5 to 9. Other than that, you don't need to worry about it because there's no g. No g here. And there's no f here. So you don't need to plus f and g. Now, this is f and this is g. So on top of the f, you plus g. On top of the f, you plus g. On top of the g, you plus f, right? On top of the f, you plus g. On top of g, you plus f. Okay. So you start from x equals to 5 and end with x equals to 9. So that's the domain. So this one start from 0 is not good. You need to start from 5 and end 9. 1, 2, 3, 4, 5, 5, 6, 7, 8, 9. Yes. 5 to 9. Looks like 5 to 9 is fine. Let me see. This is 5. And this is 9. Yes. And the shape from this shape from below 5 and the highest value about 8. So below 5, right? And to 8. To 8. Yeah, this one. Same shape, right? This shape. This shape. Okay? So this is number 25. So I'm done with session 7.4. And see you next time. Bye bye.